Roughly 50,000 years ago in what is now Iraq, there was this Neanderthal we call Nandi, and this guy, this single individual, he might just be the most injured person we've ever found archaeologically, like ever. And when I say walked, he limped, stumbled, probably dragged himself sometimes. The injuries he survived, they're absolutely mind-blowing when you really think about it. At some point in his life, he received this terrible, absolutely debilitating injury to the right side of his body. We'll never know exactly how it happened, of course. Did he chase a mountain goat too far up a cliff and fall from a great height? Was he pushed, perhaps? Was it an ambush from another group? Whatever caused this injury, his right arm was absolutely shattered, like completely destroyed. It did heal, but in doing so it became withered and small. If you're using these to fall asleep, that's why I make them. So subscribe maybe. Tell me where you're at and the time. Comments are like Berlin at breakfast, Boston at bedtime, all at once. And here's the crazy part. He also completely lost his right forearm. The bone that survived, it has this pointed angle that's left anthropologists wondering, was this the world's first successful amputation? Think about that. Someone had to stop the bleeding. Someone had to care for him day after day after day as he recovered. And here's the thing. The bone had healed in this deformed state, which shows he survived for a long time after this injury happened. Years, probably. How was Nandi able to prevent himself from dying from blood loss? How did the others around him prevent that from happening? This blows my mind. Perhaps in the same incident, a blow to the left side of his face crushed his skull and deformed his eye socket. This almost certainly resulted in him being blind in one eye, or at least having some serious difficulties with that eye. He had a healed fracture in his foot too. Injuries to his leg and knees, which probably caused him to walk with a pronounced limp. Separate to all of these injuries, he was also struck on the head again, hard enough to deform his skull. And if all of that wasn't enough, he was also partially deaf. Bony growths within both ears certainly caused some form of hearing loss. This could have been caused by the blow to the skull, or he could have had a congenital condition we call DISH. We'll never know for certain in what order these injuries were sustained. What we can say for certain, though, is that there's absolutely no way he could have survived all of this on his own, especially the loss of his arm. Others must have cared for him, brought him food, given him the care and time needed to recover. Think about that for a second. These were Ice Age humans living in small groups, constantly on the move, hunting dangerous animals with nothing but wooden spears and stone tools. Every person needed to pull their weight just to survive, and yet they kept Nandi alive through injury after injury after injury. This wasn't a one-time thing. This was years of care. You can't help but wonder if Neanderthals used local plants or mushrooms in some way to dull the enormous pain he would have felt. Living with those injuries without painkillers? Intriguingly, one Neanderthal from El Sidrun in Spain was found to have the bark of poplar wood in the plaque in their teeth. Poplar does naturally contain salicylic acid, the active ingredient in aspirin, so there's some tentative evidence that Neanderthals used plants in their environment as natural medicines, as natural painkillers. However he managed to cope, it's so interesting that what is perhaps evidence of horrific violence amongst Neanderthals, all these injuries and problems he had, is also the best evidence of their humanity, their kindness, loving each other, caring for each other. In spite of all of these injuries, he seemingly lived until he was around 40 years old, and the rest of his body is as robust and sturdy as any other Neanderthal's, suggesting he adapted to his condition and lived a physically active lifestyle. Perhaps he learned some one-handed napping techniques for making stone tools. Considering when he lived, he almost certainly had no choice but to continue on, nothing else to do about it. However, he may have been spared the most difficult of hunts. But let's back up for a second. Who were the Neanderthals anyway? Like, before we get too deep into Nandi's story, for all great apes, whether human or non-human, childhood is a time of learning and exploration, but also vulnerability. This was undoubtedly the same for Neanderthals, but sadly, so many details are now obscured by the mists of time. For some Neanderthals, childhood was, it was undoubtedly a hard time. Living life as nomadic hunter-gatherers during the Pleistocene, when Earth was colder than it is now, was probably not easy. Food, warmth and safety were not guaranteed. Stress lines in the teeth of a Neanderthal child from Western France suggest that for certain periods of their childhood, they were under a lot of physical stress, either from illness or malnutrition, possibly a result of having to struggle through a particularly hard winter. The owner of that tooth was luckier than others, though. At Mula-Gursi, the remains of at least 2 adults, 2 teenagers and 2 child Neanderthals were found, dating to around 100,000 years ago. Sadly for these people, it seems they came to a grisly end. Every bone from this cave is shattered, butchered, cut up. Clear signs of cannibalism. Like, every single bone. All the remains were found against the east wall of the cave, totally disarticulated, mixed in with the remains of other animals. It's entirely possible all of these remains come from one terrible event. How common cannibalism was amongst Neanderthals is difficult to say. It was certainly not a daily event for most, but did Nandi have to occasionally resort to it when times were tough? When no animals could be found? When the last horse had left the valley? It's certainly possible. Life wasn't all bad, though. 80,000 years ago, on what are now the beaches of Normandy, a Neanderthal family lived amongst the dunes, leaving behind bones, tools, and heartwarmingly little handprints and footprints of the 257 prints recovered. The majority belonged to children and adolescents. The youngest being probably around 2 years old. We just can't help but imagine how this family played in the sand. Did the children collect shells, leaving us a tiny handprint as they knelt down? Did their older brothers and sisters yell at them to keep up? Did the 2-year-old hold on to their mother's hand as they tentatively tiptoed on the shifting sand? And what did they think of the wolf following behind them? We're so fortunate to have even the smallest clues of family life preserved for 80,000 years. A handprint, a footprint, they're always so special. For our young Nandi, at some point he must have had to learn how to survive in this Paleolithic world of his. He no doubt had to learn how to produce the stone tools that were so essential for life, patiently learning how to nap and break rock. He would have had to learn how to process game and cook meat over the fire to provide for his hungry family. Finding such traces of children's journeys into adulthood is hard, but not impossible. Over in Cova Negra in Spain, 244 bird remains were recovered from a layer dating to the Pleistocene, mainly doves and choughs, many of them clearly butchered and burnt. Not only does this show that Neanderthals were adept at catching small prey, but the tiny scratch marks on these bones could have been made by tiny Neanderthal fingers. Perhaps they were thrown a bird to practice on as their mum and dad butchered the rest of the meal. Recent research has really started to change our understanding of Neanderthals. They emerged as an anatomically distinctive population around 350,000 years ago. And here's what's wild. Between that point and their vanishing from the record around 40,000 years ago, they survived 6 global climate cycles. 6. Far from being Arctic environment specialists stuck in frozen wastelands, they actually preferred to avoid extreme cold. They should equally be thought of as adapted to steppe tundra, forests and coasts, spreading all the way from Wales to Palestine through into Central Asia and Siberia. They were survivors in the truest sense of the word. Their brains were actually bigger than ours. The Neanderthal brain case averages 1,640 cubic centimetres for males and 1,460 for females, which is significantly larger than the averages for all living populations. The largest Neanderthal brain, a Mood 1, was calculated to be 1,736 cubic centimetres, one of the largest ever recorded in humans. But here's the thing, brain size isn't everything. Their brain organisation differed in areas related to cognition and language, which may explain some differences we see in the archaeological record. Still, calling them less intelligent would be a huge mistake. Neanderthals had large and wide noses, probably an adaptation to warm greater quantities of cold air to fuel their assumed heightened metabolism and activity levels. They were stocky, broad-chested folks living extremely active lives, perhaps even needing to eat 15% more calories than modern humans. In challenging cold climates, they may have needed 7,000 calories a day. For a family of 10 Neanderthals, that would equal roughly 3 reindeer a week. Quite a big ask. Such large calorie requirements meant Neanderthals could not have been fussy eaters at all. No doubt all the fattiest, richest parts of the body, the brains, the tongue, organs, were all widely consumed, but they probably didn't turn their nose up at humbler prey too. Grubs, insects, things like that scurrying around under logs would have made a great snack for a hungry Nandi. The more we study Neanderthals, the more we realise their diet wasn't just meat. Another Neanderthal found in Shannidar cave, Shannidar 3, had the plaque of their teeth analysed. Far from relying only on goats and wild asses, the plaque revealed he ate a diet rich in fruits like date palms, and wild seeds, and grasses like vetch. Such tiny seeds are notoriously time-consuming to gather, and the process must have been a major investment of time for Nandi's community. It's easy to think of this extra calorie requirement as a strictly logistical problem, but this increased need for calories would have had a ripple effect throughout all Neanderthal society. Was it hard for Nandi's mother to gather enough food to feed herself and breastfeed her hungry baby? How did Neanderthal women deal with this challenge? How did Neanderthals picture their landscape and assess whether there was enough resources for them all? And is it possible that this increased need for food played a part in their ultimate downfall? Did leaner, more efficient bodies expanding out of Africa have an advantage in hard times? These are questions that still haunt researchers today. The more we learn about Neanderthals, the more evidence we have of their remarkable adaptability. Like from turtles to mussels to hibernating bears, everything was on the menu, and they produced a variety of tools to get this food. Not only do we have all the stone tools that they left behind, but every now and again when conditions are right, we get glimpses of their ingenuity. Neanderthals in Italy were using beeswax mixed with conifer resin to stick their spear points to shafts, warming the mixture over the fire before applying it to their tools. They were doing prehistoric chemistry. Think about that. And they no doubt helped themselves to some honey whilst they were at it. One of the biggest gaps in the archaeological record is the fact that wood decomposes. We're largely ignorant of all the wooden artefacts that Neanderthals would have created, but every now and again we do find some. From Abric Romani rock shelter in northern Spain, a wooden tool left a trowel-shaped impression in the dirt. Are these the fragmentary remains of a Neanderthal kitchen tool or a small shovel? From Paghetti Vecchi in Italy, the remains of 58 digging sticks have been found. Nandi and his group must have produced similar tools to help them gather all the plant foods they were eating, and most famously of all, the Schöningen spears, which date to around 380,000 years ago, probably made by very early Neanderthals, found amongst the butchered remains of horses, no doubt ambushed by these Neanderthals. More recently, an intriguing wooden object believed by some to be a throwing stick has also been found. This also dates to around 300,000 years old, and it's tools like this that probably allowed Neanderthals to hunt small prey like birds. Hunting. Let's talk about hunting, because this is where this is where it gets really interesting. Neanderthals were once thought of as scavengers, barely scraping by, but we now know they were apex predators. Recent forensic analysis of Neanderthal hunting grounds has revealed them as efficient tacticians and selective butchers, traits we once thought belonged only to our own species, Homo sapiens. They weren't just randomly chasing animals around, they were strategic. They were planning ahead, like way ahead. Professor Mark White, a Paleolithic archaeologist at Durham University, has shown that Neanderthals appeared to repeatedly use the same kill sites. The remains of animals found at these sites suggest the hunters killed herd animals almost indiscriminately and then selectively butchered the fattest animals. Think about that strategy for a second. Really think about it. Neanderthals were very adept at spotting places within their home range where animals could be disadvantaged. Cul-de-sacs, bottlenecks, steep depressions, precipices, blind corners. They used the animals' flight behavior to manipulate them into these places where they killed as many animals as they could get or wanted. Because most prey species were larger and faster and perhaps more dangerous than Neanderthals, ambushing prey was a way of turning things to their advantage. The element of surprise and forced panic eliminated the speed and size advantage the animals naturally had. Horse remains found in Zwolen, Poland, suggest Neanderthals targeted harem groups by driving the animals down a grassy floodplain into natural bottlenecks produced by the river and cliffs. Reindeer remains found at Salzgitter Lebenstedt in Germany were also killed in a similar way by intercepting the herd as they made their way towards their rutting ground. Every dead animal was skinned for the fur, but only the fattest individuals with the best cuts of meat were butchered, while the rest of the carcasses were left to rot. This wasn't waste. This was selection. They had more meat than they could possibly carry, so they took the best. But how close did they actually get to these animals? We're talking about a confrontational way of hunting that required careful planning and concealment and close cooperation between individual hunters. The cut marks, or hunting lesions, on the bones of two 120,000-year-old deer provide the earliest smoking gun evidence that wooden spears were used to stalk and kill prey. Microscopic imaging and ballistics experiments they actually reproduced the impact of the blows and confirmed that at least one was delivered with a wooden spear at low velocity. This suggests that Neanderthals approached animals very closely and thrust, not threw, their spears at the animals, most likely from an underhand angle. Picture the scene. You're a Neanderthal hunter. You've tracked a prime adult deer to a narrow ravine. Your hunting party has split up, some hiding uphill with spears ready, others positioned to drive the deer toward the trap. The deer enters the ravine. Someone makes a noise. The deer panics, runs straight toward where you're hiding. You wait. It gets closer. 20 meters, 10 meters, 5. Then you leap out and thrust your spear with both hands into the deer's side, right behind the shoulder. The impact is brutal. The spear point, carefully shaped from stone and hafted to the wooden shaft with that birch tar glue you made last week, penetrates deep. The deer staggers. Your companions rush in with their spears. Within moments, it's over. That's how Neanderthals hunted. And it wasn't just deer. In 2024, researchers published evidence that a Neanderthal hunter brought down a cave lion 48,000 years ago in what is now central Germany. The big cat was still formidable, more than 300 kilograms of muscle, teeth, claw, and bone. Yet wielding nothing more than a wooden spear, a Neanderthal hunter brought the beast down with a ferocious jab to the rib cage, like just a wooden spear. It's the oldest direct evidence of Neanderthals hunting cave lions, big cats that once dominated Ice Age Europe and went extinct 13,000 years ago. The angle of the injury shows the lion was lying on its side when the killing blow came. Perhaps it was isolated, struggling to feed itself, harassed by Neanderthals throwing wooden javelins until it collapsed. Then came the final thrust. Other clues from this site are fascinating too. The cave lion's claws were kept attached to the pelt, suggesting the pelt had some ornamental value. It wasn't just stripped off the creature to get at its meat. These interactions encompassed not only the cultural use of lion body parts, but also the ability to hunt them. It only makes sense if the pelt had some symbolic significance for them. It's more than just getting some meat. It's a clear signal Neanderthals valued trophies of these animals. They intentionally left the claws in the pelt, and that's aesthetic. It would have been so much easier to cut the pelt at the wrist. The hunting groups most likely employed cooperative hunting techniques, especially in the capture of large animals. Analysis of the distribution and nature of combustion structures associated with sleeping and resting areas at one site suggest it could correspond to a Neanderthal group of between 8 and 12 individuals. Researchers note that moving complete carcasses of medium-sized and large animals required sufficiently numerous hunting parties. At Abrik Romani, the occasional transport of complete carcasses of medium-sized and large animals has been identified in all levels, regardless of occupation model. This indicates that hunting parties may have been sufficiently numerous to transport a complete or almost complete large animal, at least occasionally. 125,000 years ago, Neanderthals in Germany were hunting straight-tusked elephants, each weighing up to 11 tons or even more. Huge beasts, a huge amount of food, and an incredible display of Neanderthal hunting and teamwork. Can you imagine the coordination required? These weren't timid herbivores. These were massive, dangerous animals that could kill a human with one swipe of their trunk. Yet Neanderthals developed strategies to bring them down. Neanderthals exploited marine resources on the Iberian, Italian, and Peloponnesian peninsulas, where they waded or dove for shellfish as early as 150,000 years ago at Cueva Bajondillo in Spain, similar to the fishing record of modern humans. At Vanguard Cave in Gibraltar, the inhabitants consumed Mediterranean monk seal, short-beaked common dolphin, common bottlenose dolphin, Atlantic bluefin tuna, sea bream, and purple sea urchin. At Gruta de Figueira Brava in Portugal, there's evidence of large-scale harvest of shellfish, crabs, and fish. Evidence of freshwater fishing was found in Grotta di Castelcivita in Italy for trout, chub, and eel. At Abri du Maras in France for chub and European perch. At Kudaro Cave in Russia for Black Sea salmon. The archaeological record shows that Neanderthals consumed a variety of plants and mushrooms across their range. Most of what we know about Neanderthals comes from cave sites. Just because they're so geologically stable, not much really comes in and disturbs them. But Neanderthals certainly moved outside of these rock shelters. Finding clues about how they lived and survived when they were out in the world is so tricky. At La Folie in France, archaeologists have unearthed what they think was a Neanderthal camp. A ring of small post holes surrounded evidence of Paleolithic life like flint knapping, butchering and cooking. All the activities were carried out at different spaces, and this shows that Neanderthals had a very developed sense of space. They weren't just mindlessly bumbling around. We see this elsewhere too. At Kibara, in modern Israel, where the rubbish of daily life is organised into middens. At El Salt in Spain, we have evidence of Neanderthals burning their poo. They didn't want to leave that lying around the cave. Very house-proud of them. At Abric Romani again, it's even possible that there's some evidence of Neanderthals creating lean-tos and things like that inside of the cave to provide extra shelter. I'm sure if more wood survived to the present day, we would absolutely be amazed at what Neanderthals were capable of and how they created tools to live in their environment. All of this clearly shows that Neanderthals had the ability to inject meaning into their environment. They're very house-proud. It makes you wonder, what did Nandi think about Shannidar Cave after a long goat-hunting expedition? Was he excited to see it? Was he relieved to be sat around the warm hearth of his home? I certainly think so. The ability of Neanderthals to inject meaning into things wasn't purely practical and definitely entered the realm of art and symbolism. And when we talk about their art, we're not talking about crude scratches on cave walls. We're talking about sophisticated symbolic behavior that predates the arrival of Homo sapiens in Europe by 20,000 years. At 170,000 years ago at Bruniquel in France, Neanderthals walked 336 meters through the dark, cold, wet cave into the main chamber. Think about that journey for a second, 336 meters into total darkness. They would have needed torches, probably made from animal fat and plant fibers. They would have had to navigate tight passages, maybe crawl through sections, all while maintaining their light sources. And why? Why would you do that? Here they constructed a ring of stalagmites, and within this circle they burnt small fires on top of little piles of stalagmites. If the dates and our interpretation of this site are correct, it undoubtedly forces us to question exactly what was going on in a Neanderthal's brain. This is really incredible stuff. Evidence for Neanderthal art doesn't end there. From Krapina in Croatia and Grotte du Rhin in France, we have evidence of Neanderthal jewellery made from talons and teeth. Eagle talons in particular seem to have held special significance. A 2019 study reported that Neanderthals disproportionately butchered the golden eagle over any bird of prey or corvid species, and researchers speculated that Neanderthals viewed the golden eagle as a symbol of power like some recent modern human societies did. They weren't just eating these birds, they were collecting specific parts for symbolic purposes. From 2 sites in Spain, we have evidence of Neanderthals mixing pigments in seashells. This is chemistry, this is preparation, this is planning. They weren't just grabbing any rock and smearing it on walls. At Cueva de los Aviones in southeast Spain, a site dated to 115,000 years ago, Neanderthals had ochred and perforated marine shells, red and yellow colorants, and shell containers for mixing pigments. The shells used as containers showed clear evidence of being used as mixing vessels. This was a pigment processing toolkit. The use of ochre by Neanderthals goes back at least 250,000 years at Maastricht Belvedere in the Netherlands. Fragments of ochre processed by Neanderthals were unearthed among animal bones and stone artifacts. They represent the earliest use of ochre in Europe. But what were they using it for? The truth is, ochre had multiple uses. It could be used to tan hides, as mosquito repellent for protection against the sun or cold, for medicinal purposes, for use in extraction or processing of plants, and as an adhesive such as attaching handles to stone tools. But there's also clear evidence of symbolic use. At 3 sites in Spain, we have the possible remains of Neanderthal painting, the faint remnants of a hand stencil from Maltravieso, red ochre staining the cave wall at Ardales, and most incredibly of all, a panel of strange symbols at La Pasiega. All of these paintings seemingly predate the arrival of Homo sapiens in Europe by 20,000 years, so Neanderthals must have made them. The paintings at Ardales are particularly fascinating. Recent microscopic analysis of painted stalactites found that the red ochre pigment wasn't naturally occurring. It was brought into the cave and applied deliberately. Furthermore, archaeologists found that the pigment had been applied at different points in time over a period of 10,000 years, meaning that fellow Neanderthals likely went back to this cave and painted the stalactites again and again. The pigments are thought to be at least 64,800 years old, and now that it seems likely they were made by Neanderthals, they're probably the oldest known cave paintings in the world. Incredibly, at La Pasiega, the newly arriving Homo sapiens may have even added to the Neanderthal scene by drawing animals inside the panels. Can you imagine that? 2 species of human separated by hundreds of thousands of years of evolution contributing to the same art project. What did these paintings mean? What happened in the fires of Bruniquel? Why explore deep into these caves? One hypothesis is that they were drawn deep into caves to hunt hibernating bears, which we know Neanderthals certainly did, and once down there, their imagination took over for some reason. We'll never know for sure, but it's certain proof that there was some sort of spark behind those large Neanderthal eyes. The stereotype of mindless brutes eking out a meagre existence is permanently relegated to the past. Many scientists had long doubted whether Neanderthals were capable of producing symbolic art, but that's begun to change in recent years, thanks in part to the discovery of pigments, tiny art objects, and what might be body paint at Neanderthal sites. There remains a rump of blinkered scholars who still consider Neanderthals to be brutish savages, little better than animals, but fortunately they're a dwindling minority. Almost all objective scholars now fully accept Neanderthal art. But let's talk about something that might be even more impressive: cordage, string. At Abri du Maras, a 3-ply cord fragment made from inner bark fibres was found on a stone tool. This is the oldest direct evidence of fibre technology to date. Its production demonstrates a detailed ecological understanding of trees and how to transform them into entirely different functional substances. Fibre technology would have been an important part of everyday life and would have influenced seasonal scheduling and mobility. Furthermore, the production of cordage implies a cognitive understanding of numeracy and context-sensitive operational memory. Think about what it takes to make a 3-ply cord. You need to understand that individual fibres are weak, but twisted fibres are strong. You need to understand the concept of opposite twist directions creating stability. You need to keep track of multiple processes simultaneously. First ply, second ply, third ply, all being managed at once. Given the ongoing revelations of Neanderthal art and technology, it's difficult to see how we can regard Neanderthals as anything other than the cognitive equals of modern humans. Neanderthals maintained small populations, typically groups of no more than 20 individuals, and sometimes split up to go off into the landscape. But DNA shows they weren't all genetically inbred within single groups, and persistent long-distance stone movements point to territories covering hundreds of kilometers. This means different groups were meeting, trading, exchanging goods, and probably stories. Populations may not have been as capable of intergroup interaction and trade as later modern humans, with genetic data suggesting low population density and archaeological data indicating the sourcing of artifacts from usually no farther than 5 kilometers from the main settlement. Nonetheless, because a few Neanderthal artifacts in a settlement could have originated 20, 30, 100 and 300 kilometers away, there does seem to have been at least limited long-distance intergroup relations. A Neanderthal child's teeth analysed in 2018 showed it was born in the spring and weaned after 2.5 years, similar to modern hunter-gatherers. Children of both sexes were probably put to work directly after weaning, and upon reaching adolescence, an individual may have been expected to join in hunting large and dangerous game. Stunting may have also resulted from harsh winters and bouts of insufficient food resources. Their lives were dangerous, that much is certain. But recent research has shown something surprising. Neanderthals and early Upper Paleolithic anatomically modern humans exhibit similar overall incidences of cranial trauma, which are higher for males in both taxa, consistent with patterns shown by later populations of modern humans. In other words, life was dangerous for everyone back then, not just Neanderthals. The characterization of Neanderthals having particularly short, violent lives may be oversimplified. It was just an extremely dangerous time to be alive. However, there's something interesting in the data. Young Neanderthals, those 30 or younger, were overrepresented in the trauma group and were more likely to die while still young. This wasn't true for Upper Paleolithic humans. This suggests that young Neanderthals either were injured less or had better survival rates. Possible explanations for these patterns include cultural or individual differences in injury proneness and healing, and different long-term consequences of healed trauma, resulting from, for example, differences in injury severity or differential treatment of the injured. The injuries occurred long before death and showed signs of healing. Shannidar 1, our Nandi, survived to an advanced age despite injuries that would have been catastrophic. He would have been limited in mobility, in manual tasks, and in perceptual abilities, yet he survived. Someone so badly injured could not have survived without daily provision of food and assistance, and Shannidar 1 wasn't alone in surviving trauma. Shannidar 3 similarly sustained injury, likely requiring care. Many other Neanderthals show evidence of recovery from serious injury. Explanations for patterns of healed trauma in Neanderthals have been a matter of debate for several decades. Despite widespread evidence for recovery from injuries or survival despite impairments, apparent evidence for healthcare is given limited attention. Moreover, interpretations of Neanderthals' approach to injury and suffering sometimes assume a calculated or indifferent attitude to others. But recent work argues that the evidence for recovery and survival in Neanderthals is a reflection of managed health-related care in a social context of caring relationships. As Nandi and his family were walking over the hills pursuing goats, gathering grains, they undoubtedly ran into other humans. Some would have been Neanderthals like them, but some were not quite the same. At between 40 to 55,000 years old, Nandi lived during or even after the time period that a group of Homo sapiens left Africa, at least according to our current understanding. And here's where the story gets really interesting, because when our ancestors came into contact with Neanderthals, they didn't just fight them or avoid them, they mated with them, had children with them. You have Neanderthal DNA within you now. Right now, as you're hearing this, there are Neanderthal genes in your cells coding for proteins, influencing how your body works. Considering the fact that all non-African people have this genetic legacy, it must have occurred soon after this group left Africa. It therefore almost certainly happened in the region of Western Asia. Though to be clear, modern African people do also have Neanderthal ancestry, just less than non-Africans, around 0.3 to 0.5%. This came from later back migrations of people who'd left Africa and then returned. In other words, Nandi lived at close to the time and in the exact place where our two lineages merged for perhaps the last time. The Neanderthal genes that live in your cells could well be his, or at least belong to other Neanderthals that lived around Shannidar. Neanderthals are not our evolutionary cousins. They are, in a small way, our direct ancestors. In one sense, it's easy to imagine that these two groups running into each other was a novel event, that it was unusual for them. But more and more we find that interactions between Homo sapiens and Neanderthals was complex, occurring many times throughout our evolution. In the same way that we have Neanderthal DNA in our blood, Nandi certainly had the DNA of Homo sapiens flowing through his. Recent research has shown that approximately 6% of the Neanderthal genome was inherited from modern humans who migrated from Africa to Eurasia around 250,000 years ago. This ancient lineage of modern humans passed their DNA on to Neanderthals when they migrated from Africa to Eurasia. This means the gene flow went both ways. It really shows that Homo sapiens and Neanderthals are not really two distinct species, but rather points on a spectrum of humanity. Nandi really was every bit as human as you or I. A new analysis of DNA from ancient modern humans in Europe and Asia has determined more precisely than ever the time period during which Neanderthals interbred with modern humans. The interbreeding started about 50,500 years ago and lasted about 7,000 years until Neanderthals began to disappear. That's not a one-time encounter. That's not a few isolated incidents. That's 7,000 years of coexistence, of interaction, of living alongside each other. Most Neanderthal DNA in modern humans can be traced to a single major period of gene flow, which occurred about 47,000 years ago. This suggests there was one extended period of interaction between the two groups, rather than multiple separate events. The fact that we have Neanderthal DNA within us today shows that they were similar enough to have children with Homo sapiens, and more importantly, that these children were successful enough in their communities to pass on their DNA too. So I'm sure at some point these interactions between Neanderthals and Homo sapiens were peaceful. At least some of the time they must have been. Encounters between separate groups of our closest living relatives, chimpanzees, show evidence of both peaceful and violent behaviors. It's likely the same was true for Neanderthals and Homo sapiens. Whether or not interbreeding was successful appears to depend on the exact pair that was breeding. So far, there's no evidence of Homo sapiens genetics in late Neanderthal genomes dating to between 40 to 60,000 years ago, though this could be due to the limited sample size. It's possible this is due to the process of hybridization itself, as some species are only capable of producing offspring in certain directions. The lack of mitochondrial DNA, which is inherited through females from Neanderthals in living humans, has been suggested as evidence that only male Neanderthals and female Homo sapiens could mate, but there's also some evidence that male hybrids may have been less fertile than females. What's really striking is how much Neanderthal DNA has persisted. The genomes of all studied modern populations contain Neanderthal DNA. In all, approximately 20% of the Neanderthal genome appears to have survived in the modern human gene pool. Various estimates exist for the proportion, such as 1 to 4% or 3.4 to 7.9% in modern Eurasians, or 1.8 to 2.4% in modern Europeans, and 2.3 to 2.6% in modern East Asians. The percentage of Neanderthal DNA in modern humans is 0 or close to 0 in people from African populations, and is about 1 to 2% in people of European or Asian background, with slightly higher amounts detected using more recent methods. But what does this Neanderthal DNA actually do in modern humans? Recent research has started to answer this question. Some Neanderthal genes are responsible for certain traits in modern humans, including several with a significant influence on the immune system. Adaptive variants in genes related to immunity, skin and hair pigmentation, and metabolism have been identified. More than half of the significantly associated alleles identified are related to skin and hair traits, consistent with evidence that genes associated with skin and hair biology are overrepresented in introgressed archaic regions. Individuals with blonde hair show a higher frequency of certain Neanderthal haplotypes, whereas individuals with darker hair color show higher Neanderthal ancestry at other locations. Two further archaic haplotypes are both significantly associated with lighter skin color. There are also Neanderthal alleles that increase both sitting height and height attained at age 10 years, alleles that reduce measures of leg impedance, suggesting reduced body fat composition, and alleles that increase resting pulse rate. Neanderthal DNA in modern humans seems to also be associated with diseases such as diabetes, lupus, and Crohn's disease, which causes inflammation of the gut. The negative effects in modern humans may have been triggered by changes to our lifestyles over thousands of years. Interbreeding may have helped early modern humans adapt quickly to new environments by acquiring genes from Neanderthals who had lived there for many thousands of years. Some of the DNA is found in parts of the human genome that are associated with skin and hair, maybe giving our ancestors thicker hair and skin that helped them cope better with the colder climate. Other DNA inherited from Neanderthals seems to be involved in boosting immunity, perhaps providing a quick fix against local infections. But other times, interactions may not have been peaceful. Shannidar 3, the individual with all the plant remains in his teeth, had a vicious cut to one of his ribs. It had begun to heal, but the tip of the weapon may still have been lodged inside as the rib seemingly healed around something. Unlike Nandi, who survived for years with his terrible injuries, Shannidar 3 was not so lucky. They probably died within a few weeks of receiving this blow. Why was he stabbed like this, and who did it? We'll never know, but it's possible that it was conflict between these two groups, that this expanding group of Homo sapiens were not necessarily the friendliest of neighbours. Certainly the rest of human history would seem to prove that point. A skeleton from La Roche-Pierrot in France shows a healed fracture on top of the skull, apparently caused by a deep blade wound. This is clear evidence of violence, of interpersonal conflict, the use of tools as weapons against other humans. The most prominent behavioral context of Neanderthal tool use directed toward conspecifics is cannibalism, for which evidence has been advanced since the early days of Neanderthal archaeology. However, even the clearest evidence for butchering of conspecifics from the site of Moula Gyersi ultimately remains unresolved in terms of its behavioral and motivational context. Employing mathematical models of disease transmission and gene flow, researchers have demonstrated how the unique diseases harbored by Neanderthals and modern humans could have created an invisible disease barrier that discouraged forays into enemy territory. Within a narrow contact zone which was centered in the Levant where first contact took place, Neanderthals and modern humans coexisted in an uneasy equilibrium that lasted tens of millennia. Ironically, what may have broken the stalemate and ultimately allowed our ancestors to supplant Neanderthals was the coming together of our two species through interbreeding. The hybrid humans born of these unions may have carried immune-related genes from both species, which would have slowly spread through modern human and Neanderthal populations. As these protective genes spread, the disease burden or consequences of infection within the two groups gradually lifted. Eventually, a tipping point was reached when modern humans acquired enough immunity that they could venture beyond the Levant and deeper into Neanderthal territory with few health consequences. At this point, other advantages that modern humans may have had over Neanderthals, such as deadlier weapons or more sophisticated social structures, could have taken on greater importance. Research suggests that diseases may have played a more important role in the extinction of the Neanderthals than previously thought. They may even be the main reason why modern humans are now the only human group left on the planet. Complex disease transmission patterns can explain not only how modern humans were able to eventually replace Neanderthals in Europe and Asia, but also, perhaps more puzzling, why the end didn't come sooner. We don't yet have any evidence of art from the Shannidar region, but they certainly displayed a level of symbolic thinking in how they disposed of the dead, and this is where Shannidar Cave becomes truly extraordinary. When Nandi was originally excavated in the 1950s, the idea that Neanderthals would bury their dead was highly controversial. But now, after 70 years more research, it does seem that Neanderthals engaged in mortuary behaviour, including simple burials. The Neanderthals at Shannidar Cave are one of the best examples of this. The original excavator, Ralph Solecki, believed he'd found the remains of one Neanderthal when he was excavating. The body was lying on its side in a sort of fetal position. As he prepared to remove the body for study, he discovered the remains of 3 other Neanderthals were in the exact same spot, so close that the bones had become mixed up. The chances of 4 Neanderthals dying accidentally in the same spot seems highly unlikely. They were almost certainly placed there. To try and get to the bottom of this puzzle, in 2017, archaeologists returned to Solecki's trench to see what else they could find. As it turns out, there was yet another burial in that spot that Solecki had missed. These bones were found in a bowl-shaped depression, possibly even with their head placed resting on a stone, great evidence of deliberate burial. The dirt surrounding the body is especially dark, suggesting it's made up of decomposing material. Part of this was undoubtedly the soft parts of the body, but it does also seem that there are plant remains also mixed into this brown spot. This is where things get really fascinating and controversial. Solecki had believed that the burials at Shannidar had flowers placed over them. This was a highly controversial statement for the time, and it has been debated ever since. For many years, Shannidar 4 was thought to provide strong evidence for a Neanderthal burial ritual. Routine soil samples from around the body, gathered for pollen analysis in an attempt to reconstruct the paleoclimate and vegetational history of the site, were analysed 8 years after its discovery. In 2 of the soil samples in particular, whole clumps of pollen were discovered in addition to the usual pollen found throughout the site, suggesting that entire flowering plants, or at least heads of plants, had been part of the grave deposit. Furthermore, a study of the particular flower types suggested that the flowers may have been chosen for their specific medicinal properties. Yarrow, cornflower, bachelor's button, St. Barnaby's thistle, ragwort, grape hyacinth, horsetail, and hollyhock were represented in the pollen samples, all of which have been traditionally used as diuretics, stimulants, astringents, and anti-inflammatories. This led to the idea that the man could possibly have had shamanic powers, perhaps acting as medicine man to the Shannidar Neanderthals. Someone in the last ice age, Solecki wrote, must have ranged the mountainside in the mournful task of collecting flowers for the dead. It seems logical to us today that pretty things like flowers should be placed with the cherished dead, but to find flowers in a Neanderthal burial that took place about 60,000 years ago is another matter. However, recent work has suggested that the pollen was perhaps introduced to the burial by animal action, as several burrows of a gerbil-like rodent known as the Persian gerd were found nearby. The gerd is known to store large numbers of seeds and flowers at certain points in their burrows, and this argument was used in conjunction with the lack of ritual treatment of the rest of the skeletons in the cave to suggest that the Shannidar 4 burial had natural, not cultural origins. Some researchers have stated that the deliberate placement of flowers has now been convincingly eliminated. A recent examination of the microfauna from the strata into which the grave was cut suggests that the pollen was deposited by the burrowing rodent, which is common in the Shannidar microfauna and whose burrowing activity can be observed today. It's also been suggested that some of the pollen was deposited by nesting solitary bees. Despite these conclusions that flowers were unlikely to have been deliberately placed, researchers nevertheless conclude that the Shannidar burials, because they happened over so many years, represent a deliberate mortuary practice by Neanderthals. The discovery of a new burial at Shannidar, again suggesting some form of organic matter placed around the bodies, has reignited this argument about Neanderthals and burial. This new burial also seemingly had a flaked stone in their left hand when they were placed into the ground. Was it a prized possession? Did the Neanderthals place it in their hand out of some vague notion that they would possibly still need it? The mind boggles at the possibilities. The new excavation suggests that some of these bodies were laid in a channel in the cave floor created by water, which had then been intentionally dug to make it deeper. There's strong early evidence that the newly discovered individual, Shannidar Z, was deliberately buried. 4 of the Neanderthals, including the flower burial and the latest find, formed what researchers describe as a unique assemblage. It raises the question of whether Neanderthals were returning to the same spot within the cave to inter their dead. A prominent rock next to the head of Shannidar Z may have been used as a marker for Neanderthals repeatedly depositing their dead, although whether time between deaths was weeks, decades, or even centuries will be difficult to determine. In recent years, we've seen increasing evidence that Neanderthals were more sophisticated than previously thought, from cave markings to use of decorative shells and raptor talons. If Neanderthals were using Shannidar Cave as a site of memory for the repeated ritual interment of their dead, it would suggest cultural complexity of a high order. Shannidar has yielded very important and sometimes controversial evidence, but all of the excavation evidence from the original work is old. A key issue is testing Symbolic hypotheses of burial and ritual activity. Modern archaeological research teams have been working in the cave since 2014, reassessing the work done by Symbolic, dating his layers, and doing all the modern science not available to him. The bones of the new skeleton fit together as they would have in life. The lower body and legs would have extended into the block of sediment containing the flower burial, which also contained partial remains of 2 other adults, both female and a fragment of a juvenile. Whether the new find relates to one of these individuals is unclear. Analysis has a long way to go, but researchers should be able to test the hypothesis of the flower burial, as well as doing all the great science-based things you can do with a Neanderthal these days. Digging at Shannidar is a bit like digging on a war memorial. Thousands of day trippers visit on a regular basis. The excavation teams see exuberant dancing, picnics and wedding parties, as well as quiet people with flowers and photos and many school and college groups. For Nandi, life seemingly came to an unfortunate end too. Even though he survived injury after injury, poor vision, deafness, a missing arm, there's some evidence to suggest he finally died in a cave-in, crushed by the very rocks that had sheltered him during his hard life. Shannidar Cave is still well known for rockfalls today. It's a dangerous place to excavate. However, his story may not quite end there. It would not surprise researchers one bit if our Nandi had been buried. It's not guaranteed, of course. Neanderthals can die in accidents just like we can, but considering the effort that these ancient humans went into caring for Nandi during his life, it would not surprise anyone in the least that they would have cared for him in death too, preserving him for tens of thousands of years and giving us an insight into the incredibly difficult but also rich and loving lives of our Neanderthal ancestors. The Shannidar cave evidence continues to feature strongly in debates concerning Neanderthal capacities for compassion and mortuary behaviour. Comparison of mortuary data from the Middle and early Upper Paleolithic archaeological record shows that, contrary to previous assessments, there's much evidence for continuity between the two periods. Mounting evidence of Neanderthal culture and cognition suggests a species far more similar to us than once believed. Neanderthals maintained and might have created fire. They produced complex stone tools using the Mousterian technique. They possibly wore blankets and ponchos. They predominantly ate whatever was abundant close to home, usually big game as well as plants and mushrooms. Bands likely moved between certain caves depending on the season, indicated by remains of seasonal materials such as certain foods, and returned to the same locations generation after generation. Some sites may have been used for over 100 years. Sites showing evidence of no more than 3 individuals may have represented nuclear families or temporary camping sites for special task groups such as a hunting party. Reliable evidence of Neanderthal group composition comes from several sites. Cueva del Cedron in Spain showed 7 adults, 3 adolescents, 2 juveniles, and an infant. The footprints of La Roselle in France showed, based on footprint size, a group of 10 to 13 members where all but 1 were juveniles or adolescents. Chagirskaya Cave in the Siberian Altai Mountains showed 6 adults and 5 children, including a father, daughter, and possibly cousins. This family may have died of starvation together. How did Neanderthals disappear? This is one of the biggest mysteries in human evolution. For years, we've had theories upon theories, each trying to explain why our closest relatives vanished from Earth around 40,000 years ago. Some researchers blamed climate change. Others pointed to competition with Homo sapiens. Some suggested diseases. Others talked about demographic collapse. The truth, as it turns out, is probably a combination of all these factors, and the story is far more complex than we once thought. One of the most popular theories for a long time was that Neanderthals couldn't cope with climate change. The hypothesis suggested that during the last ice age, sharp and rapid changes in climate were a decisive factor in Neanderthal extinction because of increasingly cold and dry weather. We can find confirmation of these sharp changes in the analysis of ice cores from Greenland and from other paleoclimatic archives of continental Europe. However, when it comes to some Mediterranean areas where Neanderthals had lived since 100,000 years ago, the data tell a different story. A research group from the University of Bologna came to a fascinating conclusion after a detailed paleoclimatic reconstruction of the last ice age through the analysis of stalagmites sampled from some caves in Apulia, Italy. The researchers focused on the Merge Karst Plateau in Apulia, where Neanderthals and Homo sapiens coexisted for at least 3,000 years, from approximately 45,000 to 42,000 years ago. Data extracted from the stalagmites showed that climate changes that happened during that time span were not particularly significant. This area of Apulia appears as a climate niche during the transition from Neanderthals to Homo sapiens. Among all the stalagmites that were analysed, one was particularly relevant. This 50-centimetre-long stalagmite formed between 100 and 6,000 and 27,000 years ago. This stalagmite represents the longest timeline of the last ice age in the Western Mediterranean and in Europe. Moreover, this stalagmite did not show any trace of abrupt changes in climate that might have caused Neanderthal extinction. It doesn't seem possible that significant climate changes happened during that period, at least not impactful enough to cause the extinction of Neanderthals in Apulia and, by the same token, in similar areas of the Mediterranean. So if it wasn't climate in some areas, what was it? Recent data reveal that sudden climatic change, although crucial locally, had a limited effect on the worldwide Neanderthal population. Interbreeding and assimilation were successful only for low levels of food competition. A realistic extinction of the Neanderthal population can only be simulated when Homo sapiens is chosen to be considerably more effective in exploiting scarce glacial food resources as compared to Neanderthals. Another theory that's been gaining ground is demographic. Neanderthals likely lived in smaller bands than the dozens that make up modern hunter-gatherer groups among humans. Rough population estimates for Neanderthals drop as low as 10,000 individuals at once. Now consider that Neanderthal fossils have been found in regions as far off as England, Iraq, and Siberia. Spreading 10,000 individuals across 21.14 million square miles translates to a population density of roughly 0.0005 per square mile. Their small, isolated populations scattered throughout Eurasia were always on the brink of extinction. A survey published earlier found that among 216 paleoarchaeologists, demography was the leading theory for Neanderthal extinction, followed by environmental factors and then competitive factors. Previous theories of Neanderthal extinction had relied on assumptions of inferiority to modern humans, yet no researchers had tested the idea that they were every bit as capable of survival as us. So rather than assume differences existed between us and Neanderthals, some researchers assumed we were functionally interchangeable. Scientists aimed to investigate the null hypothesis of Neanderthal extinction. A null hypothesis assumes no difference between sample populations and that any differences between them are due to chance or error. Scientists developed a new method for inferring the timing of Neanderthal gene flow and applied it to data from ancient modern human genomes. In their population dynamics simulation, they found that various elements would have driven Neanderthals to go extinct over time, even if they weren't competing with Homo sapiens for resources. They attributed their downfall to random events rather than to some external factors. Some researchers suggest it may have been sex, not fighting, that contributed to Neanderthal extinction. Making love, not war, might have put the Neanderthals on a path to extinction. While about 2% of the genome of all people descended from those living outside Africa is derived from Neanderthals, there's very little evidence that this process went the other way. A paper raises the prospect that interbreeding with our ancestors would have reduced the number of Neanderthals breeding with each other, leading to their eventual extinction around 40,000 years ago. The behavior could have led to Neanderthal extinction if they were regularly breeding with Homo sapiens, which could have eroded their population until they disappeared. Whether or not interbreeding was successful appears to depend on the exact pair that was breeding. The lack of mitochondrial DNA from Neanderthals in living humans has been suggested as evidence that only male Neanderthals and female Homo sapiens could mate, but there's also some evidence that male hybrids may have been less fertile than females. With fewer Neanderthals breeding with each other and group sizes already small and scattered due to the environment, hybridization outside of Neanderthal family groups could have helped push the species into decline. Individual populations were only compatible in one direction with their relative species, which may also have affected breeding between Homo sapiens and Neanderthals. Neanderthals also suffered from inbreeding. When researchers look at genomes from Neanderthals, they see that they're quite inbred and therefore don't have much genetic diversity. The new discovery of Neanderthal remains of a male in a cave in southern France supports the hypothesis that Neanderthals may have gone extinct because of their isolated lifestyle. The findings tell us that multiple isolated communities might have been present in Western Europe up until their demise. According to researchers, the hypothesis isn't new and has previously been found for Neanderthals living in the Altai Mountains, which is naturally a more isolated area. A particularly intriguing hypothesis states that Neanderthals became extinct as a result of their larger head circumference compared with Homo sapiens, leading to birth complications. Researchers used population dynamics to demonstrate that a small difference in the rate of mortality during birth can cause extinction of one population. They demonstrate that sharing the same habitat with capacity constraints over thousands of years with a relatively higher death rate during birth could be the main cause of the slow decline in the Neanderthal population and its eventual extinction. We also think Homo sapiens had a competitive edge over Neanderthals. There's evidence that early Homo sapiens had long-distance trade networks, possibly buffering them against times of climate change when their preferred foods were not available. Neanderthals did not have these same extensive networks. Neanderthals had physical features that helped them survive cold climates, like large noses to humidify and warm dry, cold air, and short, stout bodies to conserve heat. But early Homo sapiens had technology that Neanderthals didn't, including sewing needles to make clothing, important during the colder periods of the last ice age. Homo sapiens also had innovative tools like bows and arrows, and seemed to have a more diverse diet than Neanderthals. Neanderthals were fairly specialized to hunt large Ice Age animals, but sometimes being specialized isn't such a good strategy. When climates changed and some of those animals went extinct, the Neanderthals may have been more vulnerable to starvation. Their ultimate extinction coincides with Heinrich Event 4, a period of intense seasonality. Later, Heinrich events are also associated with massive cultural turnovers when European human populations collapsed. This climate change may have depopulated several regions of Neanderthals like previous cold spikes, but these areas were instead repopulated by immigrating humans, leading to Neanderthal extinction. Some researchers have suggested that the Lachamps geomagnetic excursion, a short reversal of Earth's magnetic field around 41,000 years ago, may have contributed to the extinction of Neanderthals. The excursion caused a weakening of the intensity of the magnetic field, which protects Earth from harmful radiation, including ultraviolet radiation, which is dangerous to humans. Some researchers have also suggested that the Campanian ignimbrite eruption, a volcanic eruption near Naples, Italy, about 39,280 years ago, erupting about 200 cubic kilometers of magma, contributed to the extinction of Neanderthals. The hypothesis posits that although Neanderthals had encountered several interglacials during 250,000 years in Europe, inability to adapt their hunting methods caused their extinction. Kwang-Hyun Ko discusses the possibility that Neanderthal extinction was either precipitated or hastened by violent conflict with Homo sapiens. Violence in early hunter-gatherer societies usually occurred as a result of resource competition following natural disasters. It's therefore plausible to suggest that violence, including primitive warfare, would have transpired between the two human species. The hypothesis that early humans violently replaced Neanderthals was first proposed by French paleontologist Marcellin Boule in 1912. We don't have evidence of direct combat between the two species in the form of mass graves or battle sites, but we know they interacted because they interbred. Here's something that might surprise you. Some would say Neanderthals didn't go extinct because everyone alive today whose ancestry is from outside of Africa, where Neanderthals never lived, carries a little bit of Neanderthal DNA in their genes. By this definition, Neanderthals live on. Infectious diseases carried by Homo sapiens may have passed to Neanderthals who would have had poor protection to infections they had not previously been exposed to, leading to devastating consequences for Neanderthal populations. Homo sapiens were less vulnerable to Neanderthal diseases, partly because they'd evolved to cope with the far higher disease load of the tropics, and so were more able to resist new pathogens. The scenario is similar to what happened when Europeans arrived in the Americas in the 15th and 16th centuries and decimated indigenous populations with their more potent diseases. Looking at all these factors together, it becomes clear that Neanderthal extinction wasn't caused by one single thing. It was a perfect storm of demographic vulnerability, environmental pressures, competition with a closely related species, possible diseases, and perhaps most importantly low population numbers that made them susceptible to all these other factors. The reasons for their demise remain controversial, and research is ongoing. Still, you have to question whether, while extinct, if Neanderthals are really gone. After all, Neanderthal DNA lives on in people living today, the result of ancient encounters and some helpful genes. Recent scientific discoveries have shown that Neanderthal genes comprise some 1 to 4% of the genome of present-day humans whose ancestors migrated out of Africa. A multi-institution research team has developed a new suite of computational genetic tools to address the genetic effects of interbreeding between humans of non-African ancestry and Neanderthals that took place some 50,000 years ago. In a study, researchers reported that some Neanderthal genes are responsible for certain traits in modern humans, including several with a significant influence on the immune system. For scientists studying human evolution interested in understanding how interbreeding with archaic humans tens of thousands of years ago still shapes the biology of many present-day humans, this research fills in some of those blanks. Genetic research shows that most people outside of Africa have about 2% Neanderthal DNA. We think that the modern humans who spread into Asia around 60,000 years ago interbred with the Neanderthals. Since these migrants were the ancestors of all people outside of Africa, they took their small bit of Neanderthal DNA with them as they spread out across the world. Interbreeding may have helped early modern humans adapt quickly to new environments by acquiring genes from Neanderthals who had lived there for many thousands of years. But it's not all good news. Neanderthal DNA in modern humans seems to also be associated with diseases such as diabetes, lupus, and Crohn's disease. The negative effects in modern humans may have been triggered by changes to our lifestyles over thousands of years. It seems that our Neanderthal inheritance has brought both benefits and disadvantages. Long ago, Neanderthals probably infected modern humans with viruses, perhaps even an ancient form of certain pathogens. But our extinct relatives also gave us genetic defenses. Pathogens and the diseases they cause have been among the most important selective forces experienced by humans during their evolutionary history. When we look back at Neanderthals now, with all this new evidence, all these discoveries, it becomes impossible to see them as the brutish cavemen of old stereotypes. They were thinking, feeling people with material culture, symbolic art, complex social structures, healthcare systems and burial rituals. They cared for their injured and elderly. They decorated their bodies with ochre and wore jewellery made from eagle talons and shells. They ventured deep into dark caves to create art that would last tens of thousands of years. They understood the properties of different plants and used them as medicines. They made complex adhesives and cordage that required sophisticated cognitive abilities. The Neanderthals were smart. They had brains the same size as modern humans and were very clever at using local resources. What they may have lacked was the ability to expand their thinking and adapt to rapidly changing conditions in the same way Homo sapiens could. They may have lacked the extensive social networks that buffered Homo sapiens populations against environmental and demographic catastrophes. Their smaller population sizes made them more vulnerable to random fluctuations and local extinctions. In the almost 500,000 years between the ancestors of Neanderthals splitting off from the ancestors of modern humans and these other modern humans being reintroduced to Neanderthal populations, we had become such different organisms that although we were still able to interbreed quite readily, the hybrids didn't work quite as well, which means we were very far along the path to becoming distinct species. Discovering this ancient lineage of modern humans is really exciting for future research because it gives us a different lens to look at human evolution, because we don't have DNA sequences from modern human fossils from that long ago. Identifying their genetic signature in Neanderthal genomes opens new avenues for exploring our shared past. A major limitation of current studies is that we don't have genetic data from early modern humans in several key areas of the world, such as the Middle East, South Asia, and Oceania. Gathering more genetic data from these areas where early human Neanderthal interactions remain a mystery could deepen our understanding of this key moment in human history. The patterns in the DNA also suggest that interbreeding may not have been entirely random. Instead, factors such as geography or culture may have influenced which groups of humans were more likely to interact with Neanderthals, leading to different amounts of Neanderthal DNA in different populations. Uncovering when and how certain Neanderthal genes were passed down reveals how these ancient encounters shaped human adaptation and diversity. These latest findings not only show the lasting influence of Neanderthal genes on human evolution, but they also pave the way for future research. It helps us understand when Neanderthals and humans interacted, which Neanderthal genes were beneficial for our ancestors, and the forces that influenced genetic diversity and shaped the course of human evolution. Given that our own species, Homo sapiens, has not yet existed as long as the Neanderthals did, we should reconsider our tendency to underestimate them. They survived for over 300,000 years through multiple ice ages and dramatic climate shifts. They spread across an enormous geographical range from Britain to Siberia. They developed sophisticated hunting strategies, complex tools, symbolic art, and caring social structures. They were our evolutionary siblings, not our inferiors. Our understanding and appreciation of their cultural sophistication has only recently extended to their diet, their healthcare, their art, their burial practices. Only within the last few years, with new techniques and a shift in focus, have we begun to truly investigate and understand the role of all these aspects in their culture. The more we learn about Neanderthals, the more we realize that biological and cultural distinctions between them and us were relatively small. Given that we coexisted and likely interacted with them for thousands of years, the more we learn about them, the better we may understand our own past. If you look at the trajectory towards modern human behaviour, we find shell beads, bits of ochre, and ostrich shells carved with geometric designs from about 70,000 to 100,000 years ago in Africa. Now at European sites, we see that Neanderthals are following the same trajectory. We see shell beads, carved sculptures, and geometric designs on bits of bone. We see what might be Neanderthal art predating Homo sapiens art in Europe. This should lead scholars to abandon ideas of a great leap forward or upper Paleolithic revolution that was unique to Homo sapiens. It suggests that a lengthy period of geometric or abstract art preceded figurative art in both lineages. Evidence that Neanderthals were not a distinct species continues to mount. If Neanderthals were responsible for some of the Spanish cave art, then perhaps there's no real distinction between them and modern humans. Neanderthals in our line of evolution suggests that although the body was archaic, the spirit was modern. For me, the most important impact of studying Neanderthals is the better understanding of what it means to be human. This study of our closest relatives elucidates aspects of cognition, behavior, and adaptation that have implications for understanding our own species. Undergraduates across the world studying prehistory get asked a version of this question. Neanderthals were nasty, brutish, and short. Discuss. The answer, based on everything we now know, is that they were none of these things. They were human in all the ways that matter. They loved, they cared, they created, they thought symbolically, they buried their dead with what appears to be genuine emotion. They are us, and we are them, joined across the millennia by the DNA we share and the common humanity we've finally recognized.